Hi guys, so today we are looking at a very brief recording that speaks about a ray diagram question. Now, one of the first things that you recognize, class, is that your entire axis here that is used as a reference is called your principal axis. The line that is perpendicular to it is representative of the lens, and of course it can represent either a convex lens or a concave lens, right? Depends on the question. Now, in this particular question, it was stated a 5 cm tall object is placed 20 cm from a convex lens of focal length 10 centimeters. Alright, now normally, once you have a convex lens, you can have either a real image or a virtual image being formed. To know the difference, you have to compare what your object distance is to that of the focal length. So because the object distance is much greater than the focal length, you will have a real image. So the object distance here is represented by common U, and it really shows the distance of the object from the lens itself. Now, the focal length speaks about how much bending your light ray will experience as it passes through the convex lens. Now, determine by scale drawing the position of the image. So the position of the image is what is referred to as your image distance. Now, what you're looking at is basically a diagrammatic representation. Whatever scale you choose on the x-axis must allow you to represent your object distance, your focal length, as well as your image distance. Similarly, whatever scale you would, of course, choose vertically would be representative of the heights, whether it is your object height or your image height. So on the x-axis, I would have chosen perhaps 1 centimeters to 10. So I would represent 2 blocks away from my optical center what my object height is. Now, in terms of my focal length, I normally represent that on the opposite side of the lens to the object. Again, the scale is 1 centimeter to 1 block is 10. So nonetheless, I would have represented my principal focus, which is basically represented by capital F. The purpose of the principal focus is just to show when your light rays pass through the lens, how much bending is able to take place. Once I have represented my object using this particular arrow, I would then show rays of light that come from that particular height. Now, the challenge, the key is that you're going to show an first ray that is a completely horizontal ray, and that is ray 1 here. Ray 2 is a completely diagonally unbent ray that passes straight through the optical center. And of course, ray 3 is going to show when ray 1 bends and it passes through the lens, how much of that bending takes place. So when it bends and it passes through the principal focus, both rays 2 and 3 will meet at a point called the real image. Now, where those rays will meet is basically where that image is formed. Now, the length of the arrow with the image is basically speaking about the height of that image. All right, so what you will find here is basically that once you have that length of arrow, it shows that it is inverted, and the length of the arrow is also going to represent the image height. So again, based on the scale, you check how many blocks, and of course 1 block according to your scale would have corresponded perhaps to 5 centimeters. Now alternatively, you could have used your length equation, which shows 1 on U plus 1 on V is 1 on F, right? And based on that, you could have been able to work out what your value was. Now once V is positive, it also indicates that it is a object, that it is a real image.